All right, moving on to Module 5 now. And Topic A, we're going to focus on functions. And in this lesson, basically what a function is. Therefore, Lesson 1 is called the concept of a function. All right, so what we need to know about a function. A function is a rule. Okay, it is going to tell us what we're supposed to follow to find different values. Okay, but there's an important part of being a function. Okay, and a function, we say, this is like the technical definition, it assigns to each value, value of one quantity a single value of a second quantity. Oh, and I'm sorry guys, again, my sloppy writing. All right, so that's really wordy. So what the heck does that mean? Well, here's what I usually say, okay? A function, it is an equation, whatever, is considered a function if every input, okay, so that's the numbers we're dropping into the function, has exactly one output. Now, I will be honest, this is going to seem a little weird right now because what we've been doing has been linear functions, well, linear equations, but they were functions. And there was only one output for every single input we had. So if you had an equation, x plus 5, right? Or an expression, x plus 5. When you plug something, you plug the number 2 in for x, you got 2 plus 5, 7. When you put a 3 in, 3 plus 5 is 8. You got a different output for every single input we had. So don't overthink it right now because this is just the concept of a function. We're just introducing functions. And we're going to start working with things that are not necessarily linear. And there are opportunities then for when you input a number, you can get 2 different answers. There's nothing wrong with that except it's not a function. So through this whole module, we're going to be working towards that. So again, don't overthink things. Just kind of stick through me and keep an open mind. Let's look at example 1. Suppose a moving object travels 256 feet in 4 seconds. Now we're going to assume that it travels at a constant speed. All right, constant. We know that number. We can think proportional. We can think linear, slope, things like that. We can write an equation. The motion of the object can be described by a linear equation. That's what I was just talking about. Write a linear equation in 2 variables. Oh, we've done that before to represent the situation. So remember, the 8th grade way of doing this is we did distance over time. So 256 feet in 4 seconds. And remember, we set that equal to y over x. Notice we have our x values right here and our y values right here. So then when we go to solve this, we use like the cross method, cross products, and we say 4 times y equals 256 times x. Always solving for y because that's our dependent variable. So I'm going to divide both sides by 4. 4 divided by 4 is 1y. 256 divided by 4 ends up being 64. So we get y equals 64x. So our distance traveled right here, we take 64 and multiply it, that's multiplying, by our number of seconds. So very simply, if I'm filling out this table here, if I want to know in this situation, this moving object, excuse me, traveling at a constant speed, if it travels for 1 second, I can just plug that in here for x. 64 times 1 equals, well, 64. So it's traveled 64 feet. Drop a 2 in. Okay, this is what I mean by this input, right? I'm inputting these numbers in. I'm inputting a 2 now. So I'm going to go 64 times 2. And I do that multiplication, I get 128. So if I input a 2 into our function right here, I get out, my output is 128. And likewise for these. Okay, if I input a 3, 3 times 64 is 192. 4 times 64, inputting a 4, is 256, okay? A lot of the thing with a function what gets us is we start talking about it differently. We're talking in terms of this equation now is a function, and we're talking about inputs, and we're talking about outputs. But this work that we just did right here, you already know how to do, okay? It's just changing, again, how we think about certain concepts we've already done. Okay, so now we're just randomly talking about a moving object there having a constant speed. What if, though, we're dropping an object, right? And it says that the object, a stone, is dropped from a height of 256 again, okay? And it takes exactly 4 seconds for it to hit the ground. So how can it drop in 3 seconds? What about the last 3 seconds? First 3 seconds, last 3 seconds? Can we assume constant speed in this situation? Well, think about it. And actually, I'm going to show you a little video here in a second. Think about us dropping an object. Is it going to travel at the same speed? And I'm telling you, and hopefully you guys are understanding that, no. Why? Okay? Why can't we think of things at a constant speed when they're being dropped? And it's because we have this thing called gravity. Right? Gravity is going to pull closer, faster the closer you get to the center of the earth, right? So we can't think of something falling at a constant speed. Now, it's hard to tell and see, as they say, by the naked eye, but imagine you're up in a building dropping, I think, a bowling ball, right? It's not going to fall at the same speed, again, because it's going to be being pulled down by gravity. So let's watch it one more time, and you can kind of, if you watch real close, start to see it gaining speed. Think of it as even higher up. So now that we are taking this idea of gravity into play, I have this little chart here. And basically, it's just showing that at 0 seconds, obviously, they're holding the bowling ball up there, right? Object, a stone. Okay, they're doing a stone here. But after 1 second, it went 16 feet. So after 1 second, it traveled 16 feet. But after 2 seconds here, notice we just didn't go 2 times 16 to get 32. That's not 32, all right? It's falling faster. It's not a constant speed. So we can just tell from this chart, and we're going to use this chart later on, that after 2 seconds, it dropped 64 feet. After 3 seconds, 144 feet. And after 4 seconds, it's hitting the ground, and it's traveling 200, so it has traveled 256 feet. Okay? So again, this idea of a function, and what we're going to do with it is they don't have to be linear. They don't have to have that constant. Okay, that's not what makes a constant. You can have a linear function, but it doesn't have to be linear. And so again, we're just talking in this lesson about the concept of a function and what it means between, like in a table here, our input values, x's, with the relationship with our output values, y.